Greetings, members one and all of the Salivation Nation. With more demand for silver and the efficiency of monograin layer solar cells, let's explore. Yes, this comes to us from phys.org, and this is some cool science about how silver is being utilized in technology. You know, we have the push and pull where when we use science and technology to utilize silver for the wonder metal that it is for these types of things, as more demand goes for new uses for silver, less silver is needed in other applications in order to do the same thing with better technology. So sort of a push and pull there with silver demand in that regard. So as a result of their 2-year joint project, the materials researchers at the Tallinn University of Technology have improved the efficiency of next-generation solar cells by partial substitution of copper with silver in absorber material. Economic development and general growth of energy consumption have led to an increased demand for environmentally friendly energy production at lower cost. Most viable solutions can be found in the renewable energy sector. New technologies for energy production should provide clean, low-cost, environmentally friendly solutions with versatile applications, making solar energy the best solution today. Caltech's material researchers are working on the development of the next-generation photovoltaics monograin layer solar cells. Senior researcher at Caltech Laboratory of Photovoltaic Materials, Marit Kautkazik, says the production of traditional silicon solar cells that started back in the 1950s is still very resource and energy consuming. Our research is focused on the development of the next generation of solar cells, i.e. thin film solar cells based on compound semiconductors. A thin film solar cell consists of several thin layers of semiconductor materials. For efficient thin film solar cells, semiconductor with very good light absorbing properties must be used as absorber. Silicon absorber is not a suitable candidate for thin film solar cells due to non-optimal light absorption, leading to a rather thick absorber layer. Caltech researchers are developing compound semiconductor materials named kesterites, which, in addition to excellent light absorption, contain earth-abundant and low-cost chemical elements, such as copper, zinc, tin, sulfur, and selenium. To produce kesterites, Caltech researchers use a monograin powder technology, which is unique in the world. So this monograin powder technology they're developing differs from other similar solar cell manufacturing technologies used in the world in terms of its method. Compared to vacuum evaporation or sputtering technologies, which were widely used to produce thin film structures, the monograin powder technology is less expensive, Kusut says. Powder growth technology is a process of heating chemical components in a special chamber furnace at 750 degrees for 4 days. Thereafter, the mass obtained is washed and sieved in special machines. The synthesized high-quality microcrystalline monograin powder is used for the production of solar cells. The powder technology differs from other production methods, in particular due to its low cost, since it does not require any expensive high vacuum equipment. The monograin powder consists of unique microcrystals that form parallel connected miniature solar cells in a large module covered with an ultra-thin buffer layer. This, however, provides major advantages over the photovoltaic modules of the previous generation, i.e. silicon-based solar panels. The photovoltaic cells are lightweight, flexible, can be transparent while being environmentally friendly, and significantly less expensive, which means there's going to be more silver needed for these. The indicator of the quality of photovoltaics is efficiency. Efficiency depends not only on the properties of the materials used in the structure of the solar cells, but also on solar radiation intensity, angle and incidence, and temperature. The ideal conditions for achieving maximum efficiency are in cold, sunny mountains, not in a hot desert as one would expect, because heat does not improve solar cells' efficiency. It is possible to calculate the maximum theoretical efficiency for each solar panel, which unfortunately has so far been impossible to achieve in reality, but it is an objective to pursue. We have reached the point in our development where partial replacement of copper with silver in casterite absorber materials can increase efficiency by 2%. This is because copper is highly mobile in nature, causing unstable solar cell efficiency. The replacement of 1% copper with silver improves the efficiency of monograin layer solar cells from 6.6% to 8.7%, Marit Katsuk says. The two Caltech's groups of material researchers, photovoltaic materials and optoelectronic materials physics research groups, published an article, The Effect of Silver Alloying of Copper on the Monograin Powder Properties and Solar Cell Performance, in a high-quality scientific journal, Journal of Materials Chemistry. So we're seeing the foundations here of where science is going and the changing the photovoltaic field, which largely has not really changed practically in well over 70 years now. And so I think it's quite fascinating to see this technology and where it's going and the future of it, and how this efficient monograin layer of solar cells, which means that solar, and if it's more efficient and cheaper, silver will be in great demand in the future. Notice what's missing from this article, even though this is pretty far in the future before this will actually happen. What's missing here is the other material, graphene. Graphene is a way to pronounce it. I keep on wanting to say graphene. It's graphene because that is even more further off before it can be. That's nanotechnology to the nth degree, even though this is on a micro scale. Going to that route is going to take quite some time for sure. Very interesting and fascinating indeed. Post your thoughts below about this project. And another way, a look into the future, the looking glass of silver demand in the future, is quite fascinating. I'd like to extend a multitude of gratitude to you all for watching and encourage you to please rate, share, comment, and finally, while you're here, if you haven't done so already, subscribe.